So the next chapter, the most important chapter is gravitation. So here is the real difficulty in this chapter. So already those who are started studying, you can experience it. So the difficulty level of numericals is actually simple, but the calculation part of this gravitation chapter is extremely tough. So unless you have a complete knowledge about the concepts, you people cannot able to see anything in the gravitation. So this gravitation chapter is one of the major one in class 11th also. So whatever you are studying now, again the class 11th it will come. So class 11th volume 1, chapter number 7, chapter 7 is again gravitation only. So minimum 2 mark question will be asked in every year NEET, 2 to 3 or 4 mark, and JEE also. So whatever you do, any competitive exams or whatever it is, gravitation, they definitely will touch the question. So because it is related to our life, because as we are living in the earth, so we need to know the importance of gravitation concept and how it will be exerting by the earth and how we are able to survive here. So it is everything we need to know. So before beginning this chapter, you should able to remember that. So in this chapter only, the main thing we are going to study is universal law of gravitation, and as well as the applications of gravitation in scientific development, like from the Chandrayaan 3 up to the Chandrayaan 3 even you can take. So that will be also will be launched and soft landing, everything with the help of this gravitation concept only. So many key ideas will be finding in this chapter. So you must able to learn in this, understand the fact that every body in the universe is attracted by the universal gravitational force, and we will deduce or will derive the expression for the universal gravitational force in this. We'll explain the concept of mass, and we'll explain the concept of weight, and also center of mass, center of gravity, and other terms related to the gravitation I'll teach you. And we'll discuss the factors affecting the stability of a body, and how this important in different applications. So everything, calculating orbital velocity, escaping velocity, many things I will teach you for you. But it's for school level, what is there? Maximum will try to finish it on the Sunday. So now let us comes to here, this gravitation chapter. So what is about the introduction? For example, if you see, if you notice it, many of you are interested in space, or many of you are interested in knowing about the universal facts and all. So the study of the earth and the universe is always very curious and very fascinated for many scientists since ages. We are seeing from the many decades, from the history to now, around, if you go to the BC or after, whatever it is, last 200 to 300 years, last 2-3 centuries. So there is a vast kind of concepts has been developed, laws has been formed about the study of the earth and the universe. So the knowledge of the universe is like unending things, is extremely high. So the result of the work of scientists and as well as philosophers since ages, you can see some people, even our Indian philosophers, they guessed about many things about the universe. This all the thing till now what existed today, the secrets of the universe is just imagine like a single water drop in an ocean. Because day before yesterday, we launched the Chandrayaan 3 on the moon. So what is the purpose? So just to study the properties of the structural phenomena of moon at the South Pole. So what kind of surface it has, any kind of frozen water. That is the main purpose of Chandrayaan 3. Frozen water is present at the pole, South Pole of a moon. So just to sending the moon itself, it has been taken this many. But like that moon, how many millions of natural satellites are there in the world, in the universe? How many planets are there? How many stars are there in the universe? So imagine just till now what we know, the knowledge in about the space is just like a small water drop in the ocean. Because we have what? Galaxies, solar systems, motion of the planets, everything, celestial bodies, everything you can see. many things is present, like Milky Waves. It's a universe is completely extremely bigger one. So we cannot be studied. Even whatever the knowledge till today we have is a very small thing. Okay, so the brilliant thought of certain people, even you can notice many things, like even see whole world is pricing now Indian scientists, because our satellite launching is like our Chandrayaan 3 is like budget of around 640 crores is just a budget of one Hollywood film. So that much developed space technology we have at the today's. So that is why about gravitation will makes our curiosity to know about the study about the universe, about the planets, about the stars, and etc. etc. So now you can see here, 8th class you might be see that universe and the planets you might be knows. So you might be studied about the geocentric theory and the heliocentric theory. Have you heard about it? Anybody? Like we used to consider sun is the center of the solar system, or Earth is the center of the solar system. Like that, we are having a two-centric models. Am I right, everybody? Please respond. All of you. So before olden days, people used to believe that Earth is the center of solar system, and sun is revolving around the sun. So that is what we used to call as a geocentric model. Means Earth and so the theory is we can say the Earth is in a fixed position and sun is revolving around the Earth. That is what is our people used to believe. So that is only we used to call as geocentric model. So or we can say geocentric theory. This is what is our belief actually. But later what happened? Mr. Copernicus proposed a theory in the 16th century AD. So according to his theory, it is not Earth is the center, sun which is the center of the universe, and all other planets including the Earth revolve around the sun in a particular orbit. So that is the theory which we used to call as heliocentric theory. But by the time people hate to believe this, and they even Mr. Copernicus has been badly affected by the society. He is actually a teacher in the school. He has been treated with extremely bad. Even people has been thrown the stones and all, because that is the belief we have. Earth is the center of the solar system. That is how we used to believe geocentric theory. But Copernicus has been guessed. He has not been given any practical proof, but he has been guessed that Earth is not in the center. Sun is the center of the solar system and the universe. So that is the model called as heliocentric theory. But later it has been proved. But by that time he has been very worstly. It has been affected by the society. So like this, many new things is there. Planetary motion, how Earth is revolving. We all people knows. Earth is taking 365 days to revolve around the sun. Moon is taking 24 hours to revolve around the Earth. Like many things we used to know. Earth is itself is spinning around a particular axis. So many facts we people knows. Now here this is the platform. Gravitation is the platform which we can notice. We can calculate with what velocity Earth is revolving, what velocity Moon is revolving, how we can launch a satellite, what is the escaping velocity to go out from this Earth gravitation. Like many things we'll study here. Now, for you people, Kepler's laws is also deleted, but still Kepler's laws only I will start, even though we don't have a time, still I will start with the Kepler's laws. So Kepler's laws is the most important one, because from the Kepler's only, every kind of concept of gravitation has been formed. Okay, so that is why first we'll study in our today's class. The only aim is study the Kepler's laws of planetary motion. So all of you keep heading. So very important one and very interesting one. So once if you study the Kepler's laws of planetary motion, then universal law of gravitation is very, very simple. So Kepler's laws of planetary motion. So remember, Mr. Kepler has proposed the three laws to describe the motion of a planet around the sun. So that is the laws we used to call as Kepler's laws of planetary motion. So totally he proposed 3 laws. The first law is called as Kepler's first law, which is known as Kepler's first law, which is known as law of orbits. Okay, so I'll make it very simple. You don't need to worry any complicated things. So all of you observe first, what is the first law of everybody? What is the first law? Kepler's laws?
Law of orbits.
Law of orbits. Law of orbits. Now you all people tell me, you all people having an idea, is the planet, the orbits which is present surrounding the earth, surrounding the sun, is it circular in shape or elliptical in shape? Anybody? Is there ellipse like oval shape? Is there oval in shape or they are in circular in shape? Anybody? Orbits. They are elliptical orbits. Actually, they are not circular orbits. They are elliptical orbits. But for study all the laws of universal law of gravitation, we'll consider the shape, the orbital shape is a circular shape. Okay. So let us discuss the first one. All of you observe. The first law will says that the shape of the orbits of the planets revolving around the sun was originally considered to be circular. We are considering to be circular, but actually you can see they are actually the what? The orbits of the planets was not circular. They was what the shape of them? Everybody. The shape is what? All of you?
Elliptical.
Elliptical shape. Elliptical in shape. Please note it. Originally, we are considering it is circular, but it is actual shape is elliptical in shape. Clear, everybody? All of you? Please respond. Girls?
Can you please?
Yeah. So please make it. The elliptical shape. Write this sentence also, if you want. So Kepler analysis of planetary motion. Kepler analysis of planetary motion reveals that Kepler analysis of planetary motion reveals that the shape of the orbits of the planets, the shape of the orbits of the planets, the shape of the orbits of the planets was not circular. The shape of the planets of the orbits was not circular, but was, what is the shape, guys? But was elliptical in shape.
Elliptical.
Understanding? So the shape which you are seeing in the figure, I hope everybody able to see my screen. All of you, Kavya, Shivani. Yes, please.
Yes, sir.
So this is only the shape which we used to call as elliptical in shape. The shape which is present. Okay. So once again, I'll repeat. You can see Kepler's analysis of planetary motion reveals that Kepler's analysis of planetary motion reveals that the shape of the orbits of the planets, the shape of the orbits of the planets was not circular, but was elliptical in shape. So this is the shape what you are seeing, Sam. What is the shape of this one called as? Everyone? The shape which we see here, it is called as elliptical in shape. Are you clear, all of you? So now if you notice, what is Kepler's first law? Let us observe very carefully. It has two axes mutually perpendicular to each other. Can you check it, everybody? One is y-axis, another one is x-axis. Can you all able to see it, guys? All of you? So every
Yes, sir.
elliptical orbit, it has a two perpendicular, mutually perpendicularly each other. So the longer axis is called as major axis. Please write it. Longer axis we used to called as what?
Sir.
Major axis. And
Sir.
yes, Mari.
Sir, then one part, then it will be elongated at the sides, sir.
Yes, it is elliptical shape. This is called as ellipse. Understand, Mari? Oval shape.
Yes, sir.
Yes.
Both the sides are in a same size, or in one side will be elongated and
That's what basically we'll consider this, but different planets will be having a different orbital shapes. You can say slight variation, but on maximum we'll consider as elliptical shape only. Clear?
Yes, sir.
Yes. So elliptical in shape. So it has a two mutually perpendicular to the two axes, both are perpendicular. So perpendicular or not? What is the angle between them? They are perpendicular to each other. So what is the angle? Anybody?
90 degrees.
90 degrees. So everywhere it is 90 degrees. The mutually perpendicular to each other. And the longer axis is called as major axis. And the shorter one is called as minor axis. Please write it. Minor axis. Okay. Shorter one is called as minor axis and the larger one is called as major axis. Now you can see if you see that the point of intersection of these two axes is called as the center of the ellipse. Please write it. What is to call? The point of intersection is to called as what? All of you? Center of ellipse. Okay. Now, what is Kepler's first law of planetary motion? What is the heading of Kepler's first law of planetary motion? Alfin, check it everybody. What is first law? Law of orbits. All of you make attention. The law of orbits will says that. Everybody remember. So this is having a two fixed points, two fixed axes. One is major axis, another one is minor axis. And the interjunction point is called as what? Center of ellipse. Now, there are two fixed points on the major axis of the ellipse, and these are called as foci. So you can notice it, two fixed point. Here one fixed point. Here one fixed point. And here another fixed point. So this is what present in the major axis. Two fixed points. This is called as focus.
Which one is fixed, sir?
Listen. What, Mari? This one is also focus.
Which one is fixed over there, sir?
This F1 and F2. Clear? On the major axis. So now this 2 is called as foci. The plural form of focus is called as foci. F-O-C-I, foci. Okay. So F1 and F2. So what I am saying again, you see that
This place will be occupied by what, sir?
I will say you, Mari. Just wait. That is what it is. Clear? Understand?
Yes.
So according to the Kepler's first law of planetary motion, all of you observe once again, I am saying two axes are perpendicular to each other. One is major axis, another one is what? Minor axis. And on the major axis, two fixed points. What is the two fixed points is called as? Everybody? What is the two fixed points is to called as?
F1, F2.
F1 and F2. Both are called as foci. The plural form of focus is called as foci. Now I am saying the Kepler's first law of planetary motion, also called as law of orbits. So what does it mean? All of you observe. According to the first law of planetary motion, all the planets revolve around the sun in different elliptical orbits. Maybe this elliptical orbit is for Earth. Let me take. This is the planet. So Earth, this is the Earth, which is revolving around the what? Everybody? Revolving around the sun. Are you clear, everybody? I'm taking any planet. Just you take any planet. So a different planet is having different orbits. Now, sun is present either at F1 or F2, any one place. So that is only called as first law of Kepler's first law of planetary motion. Planets are revolve around the sun in different elliptical orbits, and the sun is located at one of the foci of the orbits. Maybe sun is located at this. Suppose Mr. Mari will consider here is the sun is located. No problem. Or some other will consider, Mr. Lingesh will consider here the sun is present. So sun is present any one of the foci, and planets are revolving around the sun in a particular orbit. That is only called as law of orbits or Kepler's first law of planetary motion. Do you all understand, everybody? Sun is present at any one of the foci. We have two foci. What is the two foci, everybody? What is the two foci we have? F1 and
Focus.
F1
F1
and
and F2.
F2. Now, the sun is present at any one of the foci and the planets are revolving around the sun in a particular orbit. That is only called as Kepler's first law of planetary motion. How many of you understand? If not understand, once again I will explain. So please ask me. Everybody. Hasini Sudhakar, understand? Hasini?
Sir,
Yes, ma'am. Ask me one by one, you ask. I'll say. Yes. Shivani? Agalya? Agalya is not there? Yes. Tell me, Mari, what is
Sir.
it? Yeah.
sir, you told that sun will be present in either of F1 or F2,
Or
sir.
F2. Yes.
So whether it will be settling at center of ellipse.
No, it will never be. Either at F1 or F2. That
Yes,
is
sir.
why. Yes, tell me.
Sir, to the actual planetary motion, is it present at F1 and F2?
Yes, that is the truth. That is why you can see Chandrayaan, you can notice it. When it is revolving around the Earth, not only that, everywhere orbits cannot be a particular elliptical shape or particular circular shape. They will be like this. Have you checked it, Mari?
Yes, sir.
Yeah, that is what. That is the reason. It is elliptical shapes. Clear? Understand?
Yes,
So
sir.
sun will never be at the center of the ellipse. Sun is either at F1 or F2. Are you clear, guys?
Yes, sir. So will it change its location?
No, you can consider, Mari, your choice. Yeah, that is what the Kepler's observation. So Kepler's given a theory that sun
It's
is
not true.
maybe located either at F1 or F2, but planets are revolving around the sun in a fixed orbits. That is what is the first thing.
Yes,
Do you
sir.
understand? Girls,
Yes, sir.
Shivani understood? Kavya,
Yes, sir.
Sangamitrai,
Yes, sir.
that is what. So please write it. I will say the law. And you have to draw this diagram also. That is the Kepler's first law. I will show you the animation video also. You can write it. So law of orbits, write it. According to the Kepler's first law of planetary motion, according to the Kepler's first law of planetary motion, according to the Kepler's first law of planetary motion, according to the Kepler's first law of planetary motion, right. According to the Kepler's planetary motion, all the planets revolve around the sun. All the planets revolve around the sun in different elliptical orbits. In different elliptical orbits. In different elliptical orbits. In different
Sir,
orbits. Yes, Mari.
motion all the planets revolve.
All the planets revolve around the sun in different elliptical orbits. In different elliptical orbits. And the sun is located at one of the foci of the orbits. One of the foci of the orbits. Do you all understanding? Please respond, guys. Girls. One of the foci of the orbits. Mr. Darshan, Arasani, any doubt? Mr. Lingesh?
No, sir.
Okay.
No, sir.
See, this is the one of the best animated video which I found it regarding the Kepler's laws. So you all will experience like a visual wonder, actually it is. So you just have a glance and then from this we'll proceed. Mr. Nivedan, are you clear?
The foci of the orbit.
Yeah, foci of the orbits. One of the foci of the orbits. Clear?
Yes, sir.
Agalya? Yeah, please have a glance first. Kepler's laws of planetary motion. First, totally how many laws given? Kepler? 3 laws. Okay,
3.
that is what. What happened, Amma? After elliptical orbits and the sun is located at one of the foci of the orbits. And the sun is located at one of the foci of the orbits. Okay, observe very carefully.
Objective: to understand the Kepler's laws of planetary motion.
See, this all outside the earth we used to call as celestial objects. You can see terrestrial objects. The objects which are present in the earth is called as terrestrial objects. The objects are present outside the earth. What we used to call, everybody? Celestial objects. Understanding? So we will study the motion of the celestial as well as terrestrial objects also. So observe.
The earliest known theory on planetary motion was Ptolemy's geocentric theory of planetary motion in the 2nd century, which suggested that the Earth was stationary at the center.
So who has been given geocentric model? Earth is the center. Everybody. They have shown the scientist also name. What is the name? For general knowledge, you have to remember. Okay. So he is the one who has been given the geocentric model. We used to consider Earth is the center of the solar universe.
Theory of planetary motion in the 2nd century, which suggested that the Earth was stationary at the center of the universe and the stars and the planets, including the Sun, revolved around it. Nicolaus Copernicus, in the 16th century, theorized that the Sun is fixed at the center of the universe and all the planets moved around it in perfect circles. His theory was known as the heliocentric theory of planetary motion. Tycho Brahe had researched the motion of planets for over 20 years, but did not live long enough to analyze the data he had collected. Kepler consolidated Tycho's data to put forth his 3 laws of planetary motion. Kepler's first law, the law of orbits. Contrary to the popular belief, planets don't revolve in circular orbits around the Sun. They move in elliptical orbits. So, what is an ellipse? An ellipse can be drawn using 2 pushpins placed on a straight line. Using a string, when the pencil is rotated around the pushpins, ellipse is formed. Kepler's first law states that all planets move around the Sun in elliptical orbits with the Sun at one of the foci. Kepler's second law, the law of areas.
Now see first law. First law, do you all understand, everybody? All of you? Please
Yes,
respond.
sir.
Yes, please.
Yes, sir.
Yeah.
Yes,
So what is first law? Once again, you can see that.
Sir, what is the name of the one who found
I
The
will
Sun
tell you.
at one of the
Which
foci.
one, Mari?
heliocentric theory, sir?
Heliocentric, I will say you. Don't worry. Now first you see.
Sun, ellipse is formed. Kepler's first law states that all planets move around the Sun in elliptical orbits with the Sun at one
Yes,
of the foci.
Arasani. All the bodies we used to call as celestial bodies only. Other than the Earth, whatever the objects are there, everything we can say. We can say celestial bodies. Okay. C, not SC, celestial bodies. My ellipse means it is not a complete. Everywhere radius is not same. That is what we used to call as ellipse.
That all
It is
take
all
2
the-
pushpins placed on a straight line.
You can form the ellipse. That is what he is giving the idea. Mathematics, how you can keep the 2 fixed pins. So from that you can tie a pencil and you can just draw ellipse will form. Ellipse radius is not same from the center at every point. That is what we can say. Sun is a celestial body. Yes, every body is a celestial body.
line. Using a string, when the pencil is rotated around the pushpins, ellipse is formed. Kepler's first law states that all planets move around the Sun in elliptical orbits with the Sun at one of the foci.
See, total how many foci is there? 2 foci is there. F1 and
2.
F2. Maybe Sun is located at F1 or maybe Sun is located at what? F2. And planets are revolving around the Sun in a particular orbit. That is only called as law of orbits. First law, Kepler's first law. Okay? Clear, everybody? All of you? Please respond. Next, second law. Second law is called as, right, law of areas. Second law is known as law of areas. Write it. Okay? I will give you the definitions. You write it. Observe.
Kepler's second law, the law of areas. Kepler's
Now, before listening this, I will say you. Listen, all of you. Now, for example, imagine Sun is at F1. Now, you tell me when the planet is here, is it far away from the Sun or near to the Sun? Anybody? When it is
Far
present
away.
here. Far away from
Far
the Sun.
away.
So remember, when any kind of planet will move far away from the Sun, the speed is decreases. The speed decreases because the force of attraction will be less. Force of attraction will be less. Okay, so the planet will move slowly. So when it is far away from the sun, the planets moves slow. But when it will comes to here, suppose the planet is here, and to reach here, it will be travel faster or slower, everybody? As it is closer to the sun, the force of attraction increases. Force of attraction increases so that the body will travel. The planets will start moving faster or slower, everybody? The planets moves. The planet speed increases. Are you clear, everybody? What I'm saying? Please respond. So when the planets is having greater speed, when they are closer to the sun. So when they are far away, the force of attraction is little less, so that the speed will decreases. Just have remember this point, and then we'll.
The second law states that the line joining the sun and planet sweeps out equal areas in equal intervals of time. For example, the area swept by the Earth in March and April equals the area swept in May and June. Kepler's third law,
Again, so once again I'll repeat. All of you see that? All of you observe now. Now you can notice the motion of the planet. When it is near to the sun, it is moving faster. When it is far away, the speed is less. You can notice it.
the sun at one of the foci. Kepler's second law, the law of areas. Kepler's second law states that the line joining the sun and planet sweeps out equal areas in equal intervals of time.
Okay, now let me fix here. Now, imagine at the beginning of the month, let me take this month is January, and to reach here it has came the February. Now February to March, March to April, April to June, April to May, whatever you can take. So now if I just imagine the imaginary lines between the March to in a particular period of time, not a small interval of time. So in a particular period of time, if I join the imaginary lines, particular period of time. So what Kepler's second law will say means, what is the Kepler's second law name? I said you, law of
Area.
law of areas. So remember, what Kepler's second law will say is that in a particular period of time, the planet will sweeps equal area in equal interval of time. Equal area in equal interval of time. So if you calculate the area from this point to this point, let me take this is A1. If I calculate, how I can calculate the area? By drawing the imaginary lines towards the sun. And from here to here, let me take it is A2. From here to here A3. From here to here A4. From here to here A5. From here to here A6. So it will sweeps always equal areas in equal interval of time. So that is only called as, what is to call everybody? All of you? We is to called as Kepler's second law of planetary motion, which we is to called as law of areas. Law of areas. Understanding, Ma? Everybody?
Example,
You can
the area swept by the Earth in March.
areas from March to April. If you calculate by drawing the imaginary lines to a sun and the planet, you can see April and March. March to April.
And April equals the area swept in May and June.
Okay, so it will sweep the
Kepler's third law.
that is only it is called as second law, law of areas. I hope you all understand. Please respond, guys. All of you?
Yes, sir.
Yeah.
Sir.
So according to the Kepler's second law, if you want, you can make it also. I'll say you. So I'll write it here. Just you can draw the similar structure and you can make. So what is this actually, guys? Sun it is. Understanding? But remember, you have to take a particular period of time. It must be a like month, weeks. Because if I take 1 hour, 1 minute, is it possible to observe the motion of the earth? Everybody?
No, sir.
No. So that is why you have to take a considerable time of time, like a month, 15 days or 1 week, like that you can take. It will be easily noticeable. So now sun. So let me take this point is A point and this point is B point. And next this point is I'll take it as a C point and this point is I'll take it as a D point. Now, according to the Kepler's second law of planetary motion, the area of the sectors, you can take it. What is the first sector? Mari, first sector is what? ASB. The area of a sector. What is that, everybody? You can take SAB. Next one. Area of a sector, SBC. Area of a sector, what I can take, everybody? Area of a sector, responder, SCD.
SCC.
Taken. All are what? All are equal. Understanding, Amma? So area of a SAB is equals to area of a SBC is equals to area of a SCD. That is only called as Kepler's second law. That is why it is called as, what is to say? Law of, please respond. Law of
Area.
areas. Okay. So please write it. It will sweeps equal area in equal interval of time. Sweeps equal area in equal interval of time. That is only called as law of areas. Any doubt you can ask me, or else we'll proceed further. I hope you all understand. Girls, Agalya.
Yes, sir. Yes, sir.
Abhirami, that is because of gravitational force. I'll teach you. Don't worry. You focus on the class. Are you clear now? Second law, everybody. Now, third law is more interesting one. And this is the one of the complicated one and very important one. Yes, Mari, tell me.
Sir, can you please state the rule through definition, sir?
Yeah, you can
Like in
say,
words.
according to Kepler's second law of planetary motion, according to the Kepler's second law of planetary motion, the area of sectors SAB, you have to mention A, B, C, D. SAB, the area of sectors SAB, SBC and SCD are equal. That's all.
The area of particular sectors are, the
Equal.
areas of sectors are equal.
Yes, sir. That's all, Mari. It will sweeps equal areas in equal interval of time. Sweeps equal areas in equal interval of time. That's all. Clear?
Yes, sir.
Equal interval of time. Are you clear, Amma? Girls? Everybody? So that is what you can write it. Next, third law. Kepler's third law.